So today I'm going to show you how the pmos works, the pmos transistor. It's going to be basically the same functionality as the nmos, but we're going to have opposite charges. So before we have positive charges right here on the gate, now we're going to have negative charges. It's going to be a VSG voltage that is going to come right here. So negative, a lower charge, a lower voltage on the gate is going to turn on the transistor, but it's a lower voltage difference between the source and the gate. We're gonna have a P dope region right here on the source and on the drain region. This is gonna be doped with this substrate right here. All this area right here, it's gonna dope with negative charges, which is carriers, and it's gonna be N dope. And it's gonna be the same function. It's gonna attract all the negative charges. They're gonna go right here. They're gonna create a channel region, and when the channel region voltage VSG is greater than the absolute value of the threshold voltage, that's when it's gonna turn on. Okay, so let's start with the first example. Let's first do the symbols for the PMOS. We have a transistor right here. This is the one that we're gonna use, and we're gonna have the gate, but this time we're gonna have a circle. This is the important part. This is how you know that it's a PMOS. Remember the NMOS we used to have, let me draw the NMOS. We used to have this right here. That was the NMOS. Now we're gonna have a circle right here, which is gonna mean that it's the negation of the gate, which low voltages are gonna turn on the PMOS transistor. You can see this right here with an arrow coming down to the gate, source, drain, or you can see something like this with an arrow coming out from the bulb. That means that it's a PMOS transistor. The one that we're gonna use is this one. Okay, so let's do the operation of the PMOS. You have a transistor right here. You have the gate, the negation, source, drain, gate. You have B, the G. See how these terms are going to be switched compared to the NMOS. You have plus, minus, VSD right here. First the source and then the drain. And we have BSG. And as we know, BSG is the difference between the source and the gate. We have BSD is the difference between the source and the drain. And VG is the difference between the drain and the gate. A lot of books you're gonna see that they describe this VSG as an absolute value of VGS. I don't like to do that. That's kind of confusing. They also do this one as BDS, absolute value. So I'm just gonna stick to the normal one, VSG. Okay, so what are the operations? When the only thing that we're going to use as an absolute value is going to be the threshold, that we are going to use it as an absolute value. So it's always going to be a positive value. So when is it on? It's on when VSG is greater than the absolute value of VTP. And as same as the NMOS, but with different source and drain position. When BSD is greater than BSG minus the absolute value of VTP, and as we see on the NMOS, if this is true, then it's on saturation, and when it's false, it's going to be on triad. Remember that triad is just going to be the opposite when BSD is less than BSG minus VTP. That's when it's on triad. Okay, so let's start with an example. Let's say they give us a transistor, PMOS transistor. We have the source, we have the drain, and we have the gate right here. Let's say that they tell us the BS it's a positive 6 volts. So when is it on? Remember that it's when VSG is is more than VTP. And same thing as the NMOS transistor, we're going to use VTP equals minus 0.5 volts. Okay, so when is it on? Vs minus Vg has to be greater than, since it's absolute value, we're going to have 0.5 volts. Okay, so we know that Vs is 6 volts minus Vg has to be greater than 0.5 volts. Let's multiply it by minus 1. It's going to be minus 6 volts plus Vg has to be, this is going to switch, has to be less than minus 0.5 volts. So Vg has to be less than 5.5 volts. This is going to be positive. That's going to tell us when it's on. Okay, so now let's do when is it on saturation. Let me do a different color right here. When is it on saturation? So we know that VSD has to be greater than VSG minus absolute value of VTP. Okay, so it's going to be Vs minus Vd has to be greater than Vs minus Vg minus absolute value of 0.5. Okay, so we can cancel this one. Let's multiply everything by minus 1 again. It's going to be Vd less than Vg plus 0.5 volts. And this has to be true so that it's on saturation. Now let's do when is it on triad. Let me do it right here. Let me do a different color. When is it on triad? So that it's going to be on triad when VSD is less than VSG minus absolute value of VTP. And again, we know that Vs is 6 volts, so Vs minus Vd has to be less than Vs minus Vg minus absolute value of 0.5 volts. So we can cancel this one, multiply everything by minus 1. We have Vd has to be greater than Vg plus 0.5 volts. And it's going to be on triad. Okay, and the last example. Let's say we want to know if it's on or if it's on, and if it's on saturation or triad. So let's put a Vg of 1 volt. Let's have this as 5 volts, and let's have this as 0.5 volts. This is source, this is drain, and this is the gate. Again, our VTP is going to be 0.5 volts, or same thing. Remember, it's absolute value, so it's always going to be positive. So is it on? First of all, is VSG greater than the absolute value of VTP? Source is 5. Well, let's do it completely. Vs minus Vg has to be greater than VTP. So the source is going to be 5 volts minus 1 volt. Is it greater than 0.5? It is greater than 0.5 since this is going to be 4 volts. So it's on. Now, is it triad or saturation? So let's see. Let's try VSD. Is it greater than VSG minus absolute value of VTP, you know that if it's true, it's on saturation. So let's see, VS minus VD, or let's do it the whole way. What's VSD? It's 5 minus 0.5, that's 4.5. Is it greater than VSG? What is VSG? 5 minus 1, 4 minus 0.5. It is going to be greater, so it's on saturation. This is going to be around 3.5, so this is true. Okay, and that's it for the PMOS transistor.